Well, chip companies are struggling with a variety of problems. Low power design is, of course, the one you hear about most often, but there are other very significant issues as well. Along with the cost pressures we always have, there's the problem that the complexity of chip design, the functionality, the number of gates has increased to such a level that now anyone doing big digital designs now has to move to a combination of simulation and emulation, a well-integrated combination, just to hope to do the amount of verification needed. There are a variety of other big issues. Test has become a big issue, and as we go to FinFET, you'll see a whole new range of EDA tools, three-dimensional field solvers to handle the parasitics of those fins, cell-aware technology to handle the transistor-level test that's required. And there'll be new challenges for how to do the packaging. When you have tens of thousands of pins in a package, the routing problem, the noise problem becomes even more difficult than a printed circuit board. Mentor develops most of its products internally, but occasionally we do acquisitions. Typically, we're looking for the next discontinuity, and we're also looking for key differentiating capabilities that are not available today that will be needed when the technology changes. What are the changes? Well, a good example is Tanner Design Automation. Here's a company that's been around as long as most of the EDA industry, but they provide a cost-effective, very easy to use, out-of-the-box, full-flow integrated circuit design capability that lends itself to the emerging use of cloud-based tools or very low-cost, easy-to-use tools that can also be extended to areas like photonics and MEMS. We did an acquisition of Sierra Design Automation some time ago and have complemented that with Oasis Design. Why? There's going to be a discontinuity in physical design and physical synthesis. Oasis is the next generation based on RTL synthesis that can handle tens of millions of gates and provide floor planning that is synthesis based, that can be used today for designs that challenge the capacity and performance of traditional synthesis. The Olympus place and route allowed us to integrate the capabilities of true physical verification with the complete design rule set in a flow that could handle leading edge coloring for double patterning, triple patterning, quadruple patterning, as well as handle new and emerging challenges in things like multi-corner, multi-mode analysis. And we acquired Berkeley Design Automation recently, augmenting our analog mixed signal design, which handles traditional analog and mixed signal very well, to the next generation, upping the performance hurdle to the next level to give outstanding performance and accuracy to attack the most difficult analog mixed signal designs in an area that's growing very rapidly as the Internet of Things demands more and more sensors, actuators, and information processing. Functional verification is an area of rapid change today. The discontinuity was caused because big digital designs eventually crossed the point where you could no longer do the full verification with just simulation. It now requires a combination of simulation and emulation. And that combination needs to be well integrated so that you can go back and forth between simulation and emulation, so you can use the virtual stimulus of next generation emulation to test second and third order effects with large and complex test suites. And so that you can do 1,000 times as fast or 5 orders of magnitude as fast the verification of both the software with the hardware, and do that in a very cost-effective manner. And with that combination, we've laid the roadmap ahead for the next 5 to 10 years of functional verification as complexity grows. Mentor's embedded software division is a well-kept secret, and yet it's approaching 10% of our revenue. We've been in the business in a big way since 1996 with the acquisition of Microtech, and it's grown very broadly. But it's also grown in a very deep fashion into areas like automotive embedded software, where Mentor has built the leading capability today for embedded audio and video functions, for multi-core, multi-processing heterogeneous processor systems, for built-in hypervisors with complex multi-core chips. And all of these new embedded software applications have ramped up because system design has become more and more complex, and the embedded software that goes with it now for typical automobiles is tens of millions of lines of code. So the development, the verification, the analysis, and the specific applications are now providing leverage, and Mentor's expanded that in other ways with a leading capability in AutoSAR, network analysis, and a variety of other embedded software tools, particularly for the transportation market, planes, trains, and automobiles. We are delighted to have Paul Mascarenhas join the board of Mentor Graphics. It's an honor for us, and I think it'll be a great opportunity for him, given his background as Chief Technology Officer for Ford Motor Company, as head of design for various divisions of the company, running North American engineering, a life dedicated to design of automotive functionality, particularly electronics. He's an engineer by training. He's a delightful person to be with. He's an industry leader and a spokesperson for the automobile industry worldwide, and he provides insight and guidance that we need in helping us deal with this rapidly growing focus that Mentor Graphics has on the automotive industry. In the next 5 years, I expect you will see broad adoption of integrated simulation and emulation, just because digital design will require it in a bigger and bigger percentage of all designs. I'd expect in the next 5 years that we'll see a discontinuity in the way design is done at the leading edge because of the move to FinFET and because of the physical anomalies that occur at 14 nanometers and 10 nanometers in the years ahead. So for example, new parasitic analysis will require 3D solvers to get the accurate parasitics of a FinFET that need to be used in the analysis of a design. Almost everyone will move to cell-aware tests, something which today only Mentor Graphics offers because the fins have variability in drive and current and capacitance and resistance that will create transistor level defects that have to be found and will be a substantial portion of the rejects. And then third, I expect that the impact of package complexity will cause a revolution in the way packaging is done. It will be more closely integrated with how the chip is designed to match up with trade-offs at the chip level and the package level, and the very difficult problems of analyzing parasitics between the chip and the package, and of routing very complex routes with thousands of pins on the package now becomes a problem equal or greater to the problem with printed circuit boards. And so new products, new tools will be coming from Mentor Graphics, and I'm sure from others as well, to meet this new challenge.